Hello friends, welcome to the session on 8085 microprocessor. In this session, we'll be discussing about 8085 branching instructions. In this session, we will see what we mean by branching instructions, what are the different types of branching instructions, how to write them, and we will see what will happen when these instructions are executed. Friends, as you know that you are viewing my YouTube channel, and on this YouTube channel, it is possible that you can watch many more educational videos by sitting at home only on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by branching instruction. We know that the microprocessor 8085 has a lot many instructions, and these instructions can be classified into different categories such as data transfer instruction, arithmetic instruction, logical instruction, branching instruction, and control instructions. So as far as this session is concerned, we are going to discuss what we mean by branching instructions of the microprocessor 8085. We know that in case of any microprocessor, the instruction is just nothing but a binary pattern, and this binary pattern is being designed so that when it is fed to the microprocessor, then the microprocessor will perform a specific function. As we know that 8085 has a lot many instructions available, and we know that whenever we write the assembly language program by using these instructions, then the instructions that are written in the assembly language program will be executed sequentially one after the other. But many times we need the jump from one instruction to the another instruction. That is, the sequential execution is not suited in certain applications depending upon the problem. And in such a case, we need to make the use of the branching instructions. So branching instructions are those instructions that will alter the sequential flow of the program. So such instructions are needed whenever we want to make any decision in the program. So frequently we are required to make a decision in the program, and depending upon the decision, we need to execute certain instructions based upon the value of the decision. So there are two types of the branching. The branching is being called as an unconditional branching if there is no condition, and sometimes we have a conditional branching. That is, we will check for certain condition and then we will decide which instruction to be executed. In unconditional transfer, the condition is not tested. As its name indicates, there is no condition testing. As far as the conditional transfer is concerned, then we need to check for the condition, and the condition is being checked based upon the flags. That is, the status of one of the flags is being tested in the condition. The flags such as zero flag, carry flag will be tested, and based upon the testing of these flags, we will transfer the control of execution. There are different branching instructions. So for example, we have an instruction called jump, JMP, and this instruction is an unconditional branching instruction. Now, whenever we want to achieve conditional branching, then there is a instruction called as Jcondition and then address. So here we will check for the condition, and based upon the value of the condition, the branching will take place. Now, there are several other branching instructions such as call, return, restart. So these instructions are also branching instructions, and they are frequently needed in the assembly language programs. Another indirect instruction is there for branching, and this instruction is called as PCHL instruction. So in this session, we are going to discuss what these different branching instructions are, how to write them, and what will happen when these instructions are executed by the microprocessor. So let us start with the first instruction, and this is the jump instruction. So it is being written as JMP followed by address. So in this instruction, the control is being transferred to the instruction whose address is being specified in the byte 2 and byte 3 of the instruction itself. So here we will write the address, and the address is of 16 bits, and therefore the address is being specified in the byte 2 and byte 3 of the instruction, and this address will be transferred to the program counter, and the register PC, we know that it will hold the address of the next instruction to be executed, and therefore this address, which is contained in the byte 2 and byte 3, will be transferred to the register PC. Say for example, when we write the instructions such as jump 2000H, and suppose you are at a statement of the memory location 1000H, then when this instruction is executed, then the control will be transferred to the memory location 2000H, and the instruction that is being stored at that location will be executed by the microprocessor. So this instruction is a 3-byte instruction because the address of the memory is being mentioned within the instruction itself. There is another instruction, and this is being called as a conditional jump instruction. And in this conditional jump instruction, we mention the condition. That is, it is written as J followed by condition followed by address. So initially the value of the condition is being checked. If this condition is true, then the address that is being mentioned in the instruction in the byte 2 and byte 3 will be transferred to the register PC, because we know that PC will hold the address of the next instruction to be executed. And the condition can be of this form, such as not 0, 0, no carry, carry, then odd parity, even parity, and then positive or negative or minus. So for example, we can write the conditions such as J not 0 followed by address. So whenever we write such instruction, then the jump will take place on not 0. That is, the value of Z is equal to 0. Jump if 0 address, jump on 0, that is the value of the 0 flag must be set to 1. Jump if no carry, that is the value of the carry flag is equal to 0. Jump if carry, that is if the carry flag is equal to 1, then the jump will take place to the address specified in the instruction. Jump on odd parity, JPO followed by address. So parity flag will be checked. If it is equal to 0, then the jump will take place. Jump on even parity, JPE followed by address. That is, when the parity flag P is equal to 1, then the jump will take place to the specified address mentioned in the instruction. Or jump on plus, that is the sign flag is being tested. If the sign flag is equal to 0, then the jump will take place. Otherwise, the jump will not take place. Jump if minus, JM followed by address. That is when the sign flag is equal to 1, then the jump will take place. Otherwise, the jump will not take place. So in the conditional jump, the condition is to be tested. And if the condition is true, then only the branching will occur. Otherwise, the branching will not occur. So in all conditional jumps, the control is being transferred to the instruction whose address is being specified in the byte 2 and byte 3 of the current instruction. And all such instructions are also 3-byte instructions because the address is itself mentioned in the instruction itself. There is another instruction, and this instruction is being called as a call instruction, call followed by address. So whenever this instruction is executed by the microprocessor 8085, then the higher order 8 bits of the content of PC is being moved to the memory location whose address is 1 less than the content of the stack pointer. Then the lower order 8 bits of the content of the PC are being moved to the memory location where the address of the location is SP-2. Then the content of the SP itself is being decremented by 2, and then the address that is being mentioned in the instruction itself by the byte 2 and byte 3 is being moved to the program counter PC, which stores the address of the next instruction to be executed. So the address that is being mentioned in the call instruction will be moved to the PC. So all these actions will take place whenever this instruction is executed by the microprocessor 8085. So this instruction is also a 3-byte instruction because the address is mentioned in the instruction itself. It is possible that you can make a conditional call, and the syntax for the conditional call is C followed by condition followed by address. Here also the condition is being tested, and if the condition is true, then these things will happen. That is, the higher order 8 bits of the PC will be transferred to the location SP-1. The lower order 8 bits of the PC will be transferred to the location SP-2. Then the content of the SP will be decremented by 2, and the address mentioned in the instruction will be moved to the register PC. So here the condition that you write is the same that we have seen in case of jump condition. So the same condition, that is 0, not 0, carry, not carry, all such conditions can be used here also in the conditional call instruction. There is another instruction called as the return instruction. In the return instruction, the content of the memory location whose address is specified by the register SP, that is the stack pointer, is moved to the lower order 8 bits of the PC. Then the content of the memory location whose address is one more than the content of the memory location of the content of SP is being moved to the higher order bits of PC, and then the content of the PC will be incremented by 2. So this is an instruction which you can say is a kind of opposite instruction to that of a call. That is, whenever you call, then the control of execution is being transferred to the next location mentioned in the instruction, and return means from that point of view you are again returning back to the original position, and therefore these actions will take place which are exactly opposite to that of these actions mentioned in the call. Another instruction is the conditional return, and it is being written as Rcondition. So here also the condition need to be mentioned. The same conditions can be used as we have seen in case of jump condition. And if the condition is true, then the you will find that the content of the location pointed by the stack pointer will be shifted to the lower order 8 bits of the PC. Then the content of the next location will be stored or will be shifted to the content of the program counter higher order 8 bits, and then the stack pointer content will be incremented by 2. So if the specified condition is true, then the actions specified in the return are to be performed. So here the change is that only we are testing for a condition. Otherwise, the control will continue the sequential execution. So this instruction is a 1-byte instruction. There is another instruction called as a restart. And in the restart instruction, you need to write RST followed by a number n. And whenever this instruction is executed by the microprocessor, then the higher order 8 bits of the content of the PC will be shifted to 1 less than the content of SP. Lower order 8 bits will be shifted to 2 less than the content of the SP. Then SP will be decremented by 2, and this number n will be multiplied by 8, and that number will be transferred to the program counter. That is, the address of the next instruction to be executed will depend upon the value of 8 multiplied by n. Say for example, we have been given a content of the stack pointer as 2089H. This is the hexadecimal number. And suppose the stack has the content such as 2087, 2088, and 2089. And suppose the PC initially contains 0000, 0010, 0000, 1111. Now, when this instruction, say for example, RST7 is being executed, then this lower order address is being transferred to the stack pointer 00 to the location 2087 00001111, and higher order will be transferred to the location 2088 to 00000010, and the stack pointer content will be decremented by 2 so that it will now point to the location 2087. And now the program counter will contain the number 8 multiplied by 7, that is 56 decimal, and when you convert this number into hexadecimal, then it will be 38, and therefore the content of the PC will be now 00000000111000. There is another instruction, and this instruction is being called as a indirect jump PCHL, that is jump H and L indirect, that is move H and L to the PC. So the contents of H will be moved to the higher order 8 bits of PC. The content of the L will be moved to the lower order 8 bits of PC. So content of the register H is being moved to the higher order 8 bits of the register PC, and the content of the register L will be moved to the lower order 8 bits of the register PC. So this instruction is a indirect jump instruction, and this instruction is also frequently needed whenever we go for writing the complex ALP programs for the microprocessor 8085. So thank you, friends, for viewing the session. Hopefully you have understood what we mean by branching instructions and how to write branching instructions. Whenever we see the session on writing the assembly language programs, there you will find that these branching instructions are frequently needed in the assembly language programs. Thank you all.